Let's start with an experiment right now. You don't need to go to a lab at MIT or Caltech. You just need to go to your kitchen, grab some ordinary plastic wrap, tear off a piece. Now, rub it against your hair or a wool sweater. Rub it fast, aggressively, until you can feel the heat. And now, and this is the critical moment, bring that piece of plastic close to your hand, but do not touch it. Stop just an inch away. Feel that. The hairs on your arm are standing up. You can physically feel something pulling your skin upward. You hear a quiet, dry crackle. And if you do this in the dark, you might even see tiny blue sparks. Now stop and think about how strange that actually is. In our world, the world we've been used to since birth, things only move when we push them. You want to move a coffee mug? You have to touch it with your finger. You want to open a door? You grab the handle. If you just stare at the mug and want it to move, nothing happens. We call that telekinesis, and we know it's fiction. It doesn't happen. But look at the plastic. It isn't touching your hand. Between the plastic and your skin, there is a void. Air. And yet, invisible fingers are grabbing you and pulling you up. A piece of cheap plastic from the supermarket is demonstrating the ability to act at a distance, ignoring empty space. Most people at this moment just shrug. Oh, that's just static electricity. We learned that in middle school. Rub a rubber rod, pick up some paper. Boring. But Richard Feynman, a man who understood this force better than perhaps any other human in the 20th century, would tell you that you are missing the point. By calling it static, we are just slapping a boring label on a miracle. We are sweeping the monster under the rug. Because what you just saw isn't a parlor trick. It is a fundamental glitch in our perception of reality. You think electricity is the thing that lives in the outlet. It's the stuff you pay the bill for at the end of the month. It's a useful tool that toasts your bread and shows you cat videos. But that is a lie. Or rather, that is just the tiny, tame tip of the iceberg. The force that just lifted the hairs on your arm is the exact same force that keeps your body from falling apart. Right now. The only reason you don't dissolve into a cloud of elementary particles, the only reason this chair underneath you is solid and not gaseous, is that same electrical charge. Feynman taught us to look at the world differently. He said, imagine if you could see the real picture. You would see that our world is not a collection of solid objects. It is a raging ocean of electric fields, and we are swimming in it without even realizing the depth. We are used to thinking that the main force in the universe is gravity. After all, it keeps us on Earth. It spins the planets around the sun. Gravity seems huge, heavy, inescapable to us. But that piece of plastic in your hand just proved otherwise. Think about it. The entire planet Earth, all these billions of tons of rock, iron, magma, oceans, this entire gigantic mass is pulling the hair on your arm down. The gravity of the entire planet is screaming, down, and a tiny piece of electrified plastic, weighing less than a gram, says, up. And the plastic wins. Do you understand what that means? The electrical force in that scrap of plastic is so much more powerful than gravity that it doesn't even have to try. Gravity is a weakling. It is insignificant compared to what you just woke up with a little friction. You're probably thinking, Richard, are you crazy? What electricity? I don't feel it. But I feel gravity. Every morning when the alarm goes off, it's hard to lift my body out of bed. If I trip, I break my nose. Gravity seems like the boss in this town. It keeps us in check. And that is the greatest illusion we live in. Let me tell you the truth. Gravity is a weakling. It is the weakest force in the entire known universe. It is so pathetic that it's hard to detect at all unless you have something the size of a planet under your feet. Don't believe me? Walk over to your fridge, grab a magnet. Any magnet, even that silly souvenir from a trip to Florida. Drop a paperclip on the floor. Now bring the magnet close to the paperclip. The paperclip jumps up and sticks to the magnet. Stop and look at that picture. That is a battle of titans unfolding right there on your kitchen floor. In one corner of the ring, we have planet Earth. The whole thing. 6 sextillion tons of matter. Mountains, oceans, New York skyscrapers, the Earth's core, all of it pulling that tiny paperclip down. The full power of planetary gravity is focused on keeping that piece of metal on the floor, and in the other corner of the ring, a little piece of magnetized iron in your hand. and it pulls up using electrical forces. And who wins? The little magnet. It effortlessly defeats an entire planet. Earth's gravity loses to a piece of souvenir plastic. That is how much more powerful the electrical force is compared to the gravitational one. If you ask physicists exactly how many times stronger, they will give you a number, but that number won't fit in your head. The electrical repulsion between two electrons is stronger than their gravitational attraction by a factor of 1, followed by 42 zeros. 42 zeros. We don't even have words for that in normal language. That's a billion, 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 billion. I'd get tired of saying the word billion before we got to the end of that number. If gravity were a 1-cent coin, the electrical force would be a pile of money larger than the entire observable universe. So why don't we notice it? Why, if electricity is such a monster, aren't we flying around the room? Why can we calmly drink our coffee instead of exploding? Here lies nature's greatest trick, the great balance. Gravity, it's like a clingy boyfriend. It always pulls. It only works one way. Always come to me. That's why it adds up. A rock pulls a little, a mountain stronger, the earth very strongly. But electricity has character. It has two faces, plus and minus, attraction and repulsion, and they compensate for each other almost perfectly with incredible precision. In every piece of matter, in your body, in the table, in the air, there are exactly as many pluses as there are minuses. They cancel each other out. The monster sleeps because its left arm is wrestling its right arm. But what if that balance were disturbed? Even just a little bit? What if we woke the monster up? Let's run a thought experiment. I like imagining these things. It helps to feel the scale. Imagine you're standing next to your best friend. Say, at arm's length. About a meter or 3 feet away. You're just standing there talking about baseball or the weather. You look perfectly normal. Two ordinary people. But inside you, this ocean of charges is boiling. Protons and electrons. Pluses and minuses. Their numbers are astronomical. But as I said, nature is a very fussy bookkeeper. She balances the debit and credit perfectly. The number of pluses in your body equals the number of minuses with fantastic accuracy. Now, let's imagine that this bookkeeper got distracted for a second. Let's say nature made a mistake, a tiny mistake. Imagine that you and your friend suddenly had just 1% more electrons than protons. 1%. That's trivial, right? In a bank, you wouldn't even get fired for an error like that. You are still 99% balanced. So you have a slight excess of minus. Your friend has the same excess of minus. And as we know, like charges repel. Question, with how much force would you push each other away? Try to guess. Would it be a shove, like someone bumping into you on the street? Or maybe like a punch from a professional boxer? Maybe it would throw you against the wall like in an action movie? No, you aren't even close. The repelling force created by that one measly percent of imbalance would be so monstrous that it would be enough to lift the weight of the entire planet Earth. I am not joking. Do the math yourself if you know Coulomb's law. Take the weight of all the mountains, all the oceans, all the cities, the entire mantle and core, all that unimaginable heaviness, and this electrical force arising between two people could lift it all into the air. That is what we are dealing with. You and your friend are two walking bombs, charged with enough energy to tear the planet to shreds. But you stand there, drinking coffee, noticing nothing. Because the balance is kept perfectly. The electrons hold on to the protons so tightly that this rage remains locked inside the atoms. It is a miracle that we exist at all. Living matter is a tightrope walker crossing an abyss, and the balance is so flawless that we have forgotten about the abyss. But here's what's interesting. If all these atoms are so perfectly balanced and neutral, if the pluses are hidden inside the minuses, then how do we interact with the world at all? If I am neutral and the chair is neutral, why don't I pass through it like a ghost? Why, when I touch the table, does my hand stop? The answer might seem strange to you, but you have never touched anything in your life. Ever. Look at your finger. Just look at the tip of your finger. Now touch the table in front of you or the arm of your chair. What did you feel? Solidity? Warmth? Texture? You say, Richard, I touched the table. My skin made contact with the wood. And I have to disappoint you again. That didn't happen. From the perspective of physics, no touching occurred. To understand why, we need to shrink down. Way down. Let's dive inside an atom. We all learned that pretty picture in school. A nucleus in the center, electrons flying around like little planets. It looks neat, dense, reliable, but that textbook picture is a lie. It completely fails to convey the scale. If we enlarged an atomic nucleus to the size of a marble and placed it on the 50-yard line of a huge football stadium, do you know where the electrons would be? They would be tiny specks of dust in the furthest bleachers. And everything else? All the space between the center of the field and the stands? That is void. Nothing. Ringing emptiness. Matter is almost entirely empty space. If we removed all the emptiness from the body of every person on Earth, all those gaps between nuclei and electrons, all of humanity, all 8 billion of us, would fit into the volume of a single sugar cube. So why, if I'm empty and the table is empty, doesn't my hand pass through the table? Why don't I fall through the floor straight to the center of the Earth? Here, our electricity takes the stage again. When your finger approaches the table, an incredible thing happens. The electron clouds at the tips of your atoms begin to meet the electron clouds of the table. Remember, minus and minus repel. The closer you bring your finger, the more furiously these electric fields scream at each other. Back off. This seat is taken. What you feel as the solidity of the table is not matter. It is an electrical force field. You are feeling the resistance of billions of electrons refusing to let your electrons into their territory. You are not sitting on a chair, literally. You are hovering over it. You are levitating on a tiny microscopic cushion of air created by electrical repulsion. The distance is negligible, maybe 100 millionth of a centimeter, but you have never, not once in your life, truly touched the matter of another object. And what about pain? Say you slam your fist on the table in anger. Ouch! It hurts. You think the table hit me. No. Those are your own nerve endings reacting to a sudden spike in electrical repulsion. Those are your electrons screaming in panic. Back! We're too close. This electrical signal ran up your arm to your brain, and your brain interpreted it as pain. The world we see is an illusion of solidity. In reality, it is a set of incredibly powerful force fields preventing emptiness from passing through emptiness. But if static is when charges sit still and repel, then what happens when we make them run? What is that current that kills? And here, another surprise awaits us. Because, as it turns out, electricity in wires behaves nothing like water in pipes. Okay, we've settled that things don't touch each other. But let's talk about what's happening inside your walls right now. You walk up to a wall, flip a switch, and bam, the light comes on instantly. No delay. Well, maybe a tiny fraction of a second that the eye can't notice, and you build a picture in your head. We were all explained this in school. The wire is a pipe. Electricity is water. You open the tap, the switch, and the water, electrons, rushes down the pipe at insane speed straight into the bulb, making it glow. After all, we know electricity is related to the speed of light, right? So these little guys are racing through the wires like Formula One cars. That seems logical. And it is absolutely wrong. If you could shrink down and look at the actual movement of a single electron in the copper wire of your lamp, you would laugh. Seriously, it's a comedy. Do you know how fast it's actually moving? In a DC circuit, it crawls. Literally crawls. Its speed is fractions of a millimeter per second. A snail in your garden would outrun an electron. Ketchup pouring out of a glass bottle moves faster than electric current. If you had to wait for a specific electron from the switch to crawl along the wire to the bulb on the ceiling, you'd have to wait hours for the light to turn on. But the light turns on instantly. How? How is this possible if the mailman crawls like a turtle? But the letter arrives instantly. Imagine a long pipe tightly packed with ping pong balls. The pipe stretches from New York to Los Angeles. The balls are electrons. The pipe is already full. Now, if I'm in New York and I push one new ball into the pipe, what happens in Los Angeles? At that exact same second, instantly, one ball pops out the other end. The ball I pushed is still in New York. It will take it years to get to California. But the signal of the push, the wave of pressure, traveled through the entire column almost instantly. That is what electricity is. It is not the transport of particles over long distances. It is a wave of influence. And here is another thought that will blow your mind when you pay your electric bill next month. You are not buying electrons from the power company. You have plenty of your own electrons at home. They are in the wires, in the outlet, in the toaster, in your fingers. Wires aren't empty hoses. They are packed tight with free charge carriers. The power company doesn't sell you substance. They sell you pushes. They sell you the service of jiggling your own electrons. Somewhere far away a turbine spins. It pushes electrons there. Those push their neighbors. And this wave of pushes flies to your house and forces the electrons in the filament of the bulb to shake. And it is precisely this shaking, this friction and resistance, that births light. The electrons aren't running anywhere. They are just shuffling in place and passing the baton. But if the electrons are barely moving, and the energy is transferred instantly, where is the energy located then? It's not inside the electron. It's not inside the wire. Wait, Richard. If the energy isn't in the wire, where is it? It is outside. It is around the wire, in the invisible space we call the field. And this is the most mystical part of the whole story. So we stopped on a crazy thought. Energy doesn't flow inside the wire, but outside, in space. It sounds like mysticism. How can one particle here know what another particle is doing over there? How does an electron in New York know that I pushed an electron in Los Angeles? How does the sun hold the earth without touching it? In the old days, before Newton, people had a simple answer. Angels. Seriously. People believed that behind every planet an angel was flying and flapping its wings, pushing it along its orbit. That explained the motion. You need a pusher. Then Newton came along and gave us gravity. He said, no need for angels. There is a law. The sun pulls the earth. And we calmed down. We learned to calculate orbits. But Newton left us a terrible riddle that kept physicists awake for 200 years. The mechanism. How does it work? If the sun disappears right now, will the earth fly off into the dark immediately or after some time? How does empty space transmit the command, pull? It's called the problem of action at a distance, and it drove everyone crazy. Until Michael Faraday appeared, a guy who didn't even really know mathematics. He was a bookbinder. But he had an amazing imagination. Faraday said, forget about the void. There is no void. Imagine a swimming pool, a huge, smooth pool of water. In one corner, a bobber is floating. In the other corner, you stand. You aren't touching the bobber. But if you slap the water next to you, a few seconds later, the bobber in the far corner will jump. You didn't touch the bobber. You touched the water. And the water touched the bobber. Faraday proposed an idea that changed everything. The universe is a swimming pool. It is filled with an invisible substance we call the field. Electric field, magnetic field. They are everywhere. Right here in front of your nose, inside your body, in the vacuum of space. When an electron sits in space, it doesn't just sit there, it changes the space around it. It creates tension in this pool. It spins an invisible web. And when another electron falls into this web, it feels a force. It doesn't feel the first electron. It feels the field at the point where it is standing. This solves all the problems. No action at a distance. Everything is local. The electron interacts with the field right here. And here's the most amazing thing. This field is real. It isn't just a mathematical trick to make the equations balance. The field has energy. It has momentum. If you kick the field, it kicks you back. Back to our wire. When you turn on the current, you create a storm in the electromagnetic field around the wire. You create waves in this pool, and the energy, the very stuff that toasts your bread, flows in this field, dives into the wire, and gives itself to the electrons, forcing them to heat up. This changes our view of reality, doesn't it? We are used to thinking that only particles are real. Balls, rocks, atoms, and the space between them is just nothing. The stage on which the action happens. But physics tells us the opposite. The stage is the main character. The field is the reality. And particles might just be knots in this field. Places where the field has tied itself into a tight ball. We live inside a giant, vibrating web. And if you tug on a thread here, the universe shudders over there. And here the question arises, what happens if we start tugging on this web very fast? Up and down, up and down. We launch a wave that runs through the field. Do you know what we call that wave when it touches our eyes? Think for a second about what is happening right now. You see me, or you see the text on the screen. How does that happen? Somewhere far away, maybe on the sun, or maybe in the filament of a light bulb, there is an electron. And someone shook that electron. It has an electric field that stretches across the entire universe, as we found out. And when the electron jiggles, a wave runs along this field. This wave flies through space at a speed of 300,000 kilometers per second. It flies into your eye and hits the electrons in your retina. They start shaking in response, and your brain says, "Oh, I see light." The light that allows us to see the beauty of the world is simply a radio transmission from one electron to another, and the difference between a radio wave, a microwave, red color, blue color, and an X-ray is only in how fast we shake that electron. Shake it slowly, and you get a radio wave. Shake it a bit faster. Heat comes off. Shake it even faster. You see red light. Shake it like a maniac, and you get ultraviolet that burns your skin. It is all the same thing. It is all the dance of the electric field. Now look at heat. Rub your hands together. Feel the warmth. What is that? That is motion. When you rub your hands, you force the atoms of your skin to push, to bang against each other, to vibrate faster. Heat is just the jiggling of atoms. And here we come to my favorite example, fire. Look at a log burning in a fireplace or at a campfire. What is it? What exactly are you seeing? Ancient people thought it was spirits or magic. Chemists will tell you it is the rapid oxidation of carbon. But let's look at it through the eyes of a physicist who knows about electricity. Where did the wood come from? It grew. And how did it grow? It took air, carbon dioxide, and water. But to turn air into solid wood, you need to rip oxygen away from carbon. That is very, very hard. The atoms hold on to each other with a death grip, an electric grip. To tear them apart, you need energy. The tree takes this energy from the sun. Sunlight, those very waves of the electric field, flies in, hits the leaf, breaks the bond, throws away the oxygen, which we breathe, and keeps the carbon to build the trunk. So what is a tree? A tree is a battery. It is canned sunlight. It is captured energy, locked in the electrical bonds of the trunk. The tree stored it for years, and then you set it on fire. What happens? You break the lock. You allow the oxygen to snap back onto the carbon. They join back together with a click, snap, like magnets. And in the moment of that impact, in the moment of reunion, all that energy that was stored for years bursts out. That furious jiggling of atoms turns into heat. And the electrons, shaking from the impact, begin to emit light. Look at the fire. The yellow light of the fire is the same sunlight that fell on a leaf 30 years ago. It was hidden in the wood like a genie in a bottle, and now it is coming back out. The heat of the fire is the heat of the sun, stored in chemical structure. Is that not fantastic? You don't need to invent fairy tales about dragons and magic for the world to be interesting. Reality, if looked at through the lens of physics, is far more magical than any fairy tale. A piece of wood in the fireplace is a star's battery that you are discharging to keep warm. And all this variety, the solidity of the table, the light of the lamp, the heat of the fire, the working of your brain, all of this is different dances of the same lady, the electrical force. Before we started this conversation, you looked at the world and saw just things: chair, table, wall, boring, gray, motionless objects. But now I hope you see what I see. You look at this quiet, calm glass of water on the table. It seems so peaceful. The water isn't moving. Nothing is happening. But now you know the truth. You know that inside that glass, a hurricane is raging. Billions of electrons and protons are whirling in a frantic dance. The electric fields there are so monstrously powerful that if we disturb the balance in that glass by just a tiny fraction of a percent, the explosion would destroy the entire city. Locked in this small volume of water is enough energy to boil all the oceans of the world if we only released it all at once. But nature keeps it in check. Plus, perfectly overlaps with minus. The monster sleeps. And that is why the water seems quiet and safe to you. Doesn't that make the glass of water more amazing? Doesn't knowing about the hidden storm make the silence more valuable? We live in a world woven from light and electricity. We ourselves are patterns of electrical signals. Your thoughts, your memory, your love for someone, your very awareness of this moment. It is just the shimmering of electric current in the neurons of your brain. We are the universe's way of looking at itself. We are electricity that gained consciousness and started asking questions. And that is the greatest adventure there can be. Don't be afraid of physics. Don't be afraid of formulas. It is just the language in which the book of nature is written. And this book is open. You don't need secret clearances or expensive equipment to read it. You just need curiosity. And a piece of plastic wrap in the kitchen. So the next time you just sit in silence, when you reach for a glass of water, stop for a second. Feel the coolness of the glass with your fingertips. Remember that you are not actually touching it. Remember that you feel the breath of a force field. And smile at the fact that you are holding a tamed storm in your hand, which by some incredible accident and mercy of nature allows you to simply take a drink of water. Thank you for listening. So now go and look at the world with new eyes.